Hello everyone, welcome back to Northeast Wisconsin Technical College. I'm Matt Schmelzer here with Practical Machinist, and today we're going to talk about boring bars and boring holes. A project we have here that our students work on is part of their injection mold. So they have a plate here that they have to precision bore some holes in it for these leader pins to press fit in. So they got a tolerance of plus or minus 1/1000 on these bores. So the best option is to go through it with a boring bar. I got a couple of the different styles that we have here at the college. First of all, I'm going to talk about the cutting tools themselves, and these are our boring cutters that will get placed into these heads. A couple different styles. I have some high-speed steel versions, different lengths, different diameters. I also have one that has cemented carbide in it, and then also one different variation where it's got a inserted high-speed or carbide tipped insert, whatever we decide to place into it. So these are a couple of different versions. Now, one thing about these high-speed steels, we tend to use these in the classroom here. These can be resharpened, reground. One thing to always consider though, whenever we resharpen them, we always want to just take material off of the very bottom. We never want to remove any material off of the face of these cutters, because of course that cutting edge is placed right on the center line of this tool. So these are our boring cutters. Next thing over here is looking at the boring heads themselves. This one right here, just a real basic offset boring head. Does have a micrometer dial on it in increments of 1/1000 of an inch. This is pretty versatile. It gives us a couple different options for placing our tools in it. These use 3/4 inch diameter shank tools, so it gives us a couple of different positions to place the tool in depending on our bore size and our cutter size. So we can place it in those two positions, and also to really reach out to a large diameter bore to increase the capacity. So the idea is we're always looking to find the shortest, largest diameter for the application. So just our simple offset boring head. Now this one here is a Weldon style, so it does have a flat to locate in one of our holders, or we could place it into a collet also. It does have 3 lock screws on the side. A lot of times we'll just lightly snug the 2 outside ones just to take care of any backlash, and lock and unlock just the center screw itself. So this is what we'll be using today in our project. Another variation is our multi-purpose boring head here, another offset boring head for one of our larger conventional machines. It also incorporates a micrometer dial, and again the 3 different positions on the face along with on the side also. This one here is a little bit unique because not only can we bore, but we can also spot face with this tool in a larger machine, and we can adjust our diameter as it's rotating. We could either place a pin in here that keeps this ring secured as the tool rotates, and as it rotates every revolution, at this point it's set to move out 5/1000 every revolution. But by just locking in and engaging our 2 screws, we can increase it from 5 to 10/1000 and then 10 to 15/1000. Every revolution that this rotates, it increases its diameter. So a very versatile boring head. The next 3 over here, when we get into our CNC machining centers, of course we have these style here, Cat 40 adapters. Again, these have a small micrometer head. These are, of course, our inserted carbide. One here specific for Cat 40. This one here, Weldon style shank, again with our micrometer dial. And then to the latest ones that we're using here that have a micrometer dial on the back side, and also have a microchip for storing any kind of tool information on this specific tool. This is a little more modular. We can change our cutting heads along with our insert holders to configure it to a few different styles there. So I'm going to go ahead and get our parts set up in the milling machine. We're going to go to our offset boring head, and I'll go through the procedure of boring a hole. Alright, so we have our parts set up in our milling machine here, just our vertical turret mill. A couple of procedural things is we cleaned the table down, stoned it. Our vise is on the table, indicated straight with the x-axis and tightened in place. We got our part set up in the vise here, secured, and we actually went ahead and located the center line of our first hole. So I went ahead and zeroed out my dial, my digital readout at that location. And one other thing to mention too, if you haven't seen our last video, we went through and we trimmed the head of this machine square. So basically our spindle is perfectly square to the table. So if you haven't watched that yet, go ahead and check that out. That's something we want to make sure our head is perfectly square to our table before we start boring holes. That's going to ensure a nice, true square hole on our part. So we got everything set up on the machine here. We'll go ahead and go over the workbench and we'll go over all the tools that we'll be using today to bore this hole out. All right, so on the table here, I got all the tools that we're going to use today to bore the hole out. Of course, I got my offset boring head that I'm deciding to use for this job, already set up in a Weldon style holder. We got our selected cutting tool that we're going to be using. Again, this is just nice and short. I don't want to be any longer than I have to have any rigidity issues or chatter problems in my boring operation. I have a couple sets of hex keys that we're going to be used for making our adjustments. Of course, a micrometer, telescoping gauge to do our measurement. I'm going to use a little bit of dicum for establishing our reference in the bore, and then a straight edge. So I already have the holder mounted into our milling adapter, a Weldon holder. So the next thing to do is to get our cutter mounted in our offset head. So I just got a little block here to assist me to hold this in place. So I'm going to go ahead and get this positioned now. I'll go ahead and, for the size of our bore, I'm going to decide to use the center hole in this. If I go out to the outside hole, that's going to increase the diameter way too big for what we're doing. So I got my cutter placed in here. On this specific holder, there is a lock screw to locate this in place. Now, on these cutters themselves, there is no flat on the shank of these tools, all right? There really is no way of locking these in place. So to get this position right, I'm going to place it in the offset boring head here with my cutting edge facing away from the micrometer dial. That way when I go clockwise direction on the micrometer dial, it's going to move the insert out to increase the diameter. Now, without having a flat on there, this thing could be in any kind of rotation position also. So one thing we want to do is make sure that we line our cutting face up to be in line with the movement of this boring head, or the dovetail of this head. So I'm just going to take my straight edge here, I'm just going to place it on that cutting edge, and I'm just going to rotate it and visually look down until it is aligned with the edge of my boring head here. So I have it nice and aligned. This doesn't have to be exactly perfect, but we do want it fairly close. So again, just placing this straight edge along that cutting edge, just get it nice and straight with the tool, and now I can hold that in place and tighten down my lock screw. And just one more double check, place it down the cutting edge, and it is right in line with my tool. All right, so we're back to the milling machine. We have our offset boring head mounted in the spindle. Again, we did an alignment with our cutting edge to make sure it is parallel to the dovetail of the machine. Now these boring heads, they do come in a few different variations, particularly referring to the micrometer dial. They have one called direct reading and the other one called indirect reading. Direct reading, when I rotate this dial 10 thousandths on the dial, it's going to remove 10 thousandths off the diameter, meaning 10 thousandths on the dial, it only moves 5 thousandths with the insert, all right? Indirect reading, if I rotate this dial 10 thousandths, it moves the insert 10 thousandths. That's going to end up with 20 thousandths coming off from the bore itself. So one thing we want to make sure is that we determine what style boring head this is before we do any cutting. So in order to do that, I'm just going to position this with the machine, and I'm just going to put it in low gear now so it doesn't rotate. And I'm just going to verify direct or indirect using my indicator here. So I'm just going to set up my 1-inch travel indicator on a mag base. I have it fixed to the table. So I'll go ahead and zero out my dial on my indicator. And I'm just going to simply take my hex key and I'm going to make an adjustment on here. And I'm just going to rotate it 10 thousandths of an inch. So there's 5/10,000ths. So we can see on our dial it moved 5 thousandths. So I rotated my micrometer dial on the head 10 thousandths, it only moved 5. That's going to result in 10 thousandths coming off of my bore diameter. So this is a direct reading. I adjust this 10 thousandths, it takes 10 thousandths off the diameter of my hole. So now that we got that determined, we can go on to the next step here. All right, the next step is to get our milling machine set up for this boring operation. I did go ahead and I locked all of my table locks, of course my cross slide and my knee. Now we're going to look at the other device on this machine. It's the power feed, and this is going to power feed our quill to make the cut. Now we got an engagement lever here, so I'm going to go ahead and just rotate that into the engagement position. Right there. So now when I turn the machine on, run the spindle, my power quill will be activated. Of course, we have our engagement lever on and off, and then of course our push-pull for our clockwise, counterclockwise direction, either feed down or feed up. The next thing is we've already pre-drilled our hole. We do have roughly a 1/16 of an inch of material to come out of that bore, so we're going to do a series of rough cuts. So rough cuts, generally we're going to feed at a higher rate. So over on the left-hand side of my machine, I have 3 options for feed rate in inches per revolution. One being 3 thousandths per revolution, 1 thousandths per revolution, and of course down here, 6 thousandths per revolution. Now I have this already in position for 6 thousandths per revolution. So that's what we're going to feed this boring bar for this roughing operation. So next we can go ahead and establish our reference in the bore. So of course with the insert out of the hole, I'm just going to go ahead and just take some dicum, and I'm just going to just put a little bit of dicum on here because we'll actually be lightly scratching the surface of this bore. Now again, we're going to be using the power feed. So before I go any further, I want to make sure that I bring this tool all the way through and observe the position as it comes through the bottom side of the part, and at that point right there. I want to make sure I have plenty of clearance from my boring head to the surface of the part. And I'll go ahead and set my quill stop at this point. That way, when the quill gets to this position where it breaks completely through the hole, it's going to disengage my power feed. So now I can go ahead and just raise it up very lightly, and I'm going to go ahead and lock my quill. That way I don't get any movement out of this. At this point, I'm going to grab my hex key, and I will lightly unlock my lock screw, and now I can take the next hex key and I'll make an adjustment on my micrometer dial. Now again, there is a reference line etched into the offset boring head here, which refers to the markings on the dial. So again, as I turn this thing clockwise, this is going to increase my bore size. Counterclockwise will decrease my bore size. Now there is a certain amount of backlash in this also. So one thing to always consider, if you overshoot the particular number on the dial you're looking for, you need to make sure you go past that number and come back to it in a clockwise direction, the same direction we're going to increase the bore size. So you can't simply just reverse this. There is backlash where the head is not moving at all. So you have to go past it, usually a half a revolution, and then come back to the number you were aiming for. Just a little tip there. So at this point, I'm going to go ahead and turn the light on so I can actually see down into the bore here, and I'm going to bring the tip of the cutter out until it scratches my dicum. So I'll go ahead and increase my bore size. I can see I have quite a ways to go here. I'm going to bring this down in just a little bit further. I can see down into the hole with a little bit of reflection. And I back it up a little bit, but I don't turn the dial as I reverse it. And I'll just rotate it, back it up, make an adjustment. I'm just moving just a couple of thousandths every turn. And now I can see it's just starting to make a chip in that bore. So I would say at that point, I just established a reference to the existing hole. Now this is a drilled hole. It may not be in perfect location. It may not be perfectly round, but this is just a place for us to start. So now I can go ahead and bring my head up. All right, so we established a reference in the bore just by very lightly scratching the dicum. And at that point, it just so happened on our dial, we ended up right at 0 on our indicator mark. That doesn't always happen. But at this point, I'm just going to increase my bore size 10 thousandths. Now again, I have roughly a 1/16 of an inch, but I want to get a nice true cut bore to take a measurement. So I'm just going to rotate this clockwise again. That's going to increase my bore size 10 thousandths of an inch. Now again, because this is a direct reading, this should take 10 thousandths off of the diameter. And now I can go ahead and lock my screw. And I'm not putting a ton of pressure on it, just enough to keep that from moving. So right now, we're ready to take our first cut so we can start measuring where our boring bar is set to. I already have the RPM set correctly. This is aluminum, so we're roughly 1,000 RPM with high-speed steel. I'm going to go ahead and turn our spindle on. And now you can see again our quill feed is activated. It's rotating. One thing to just check, right now the dial is rotating clockwise. When I go to engage this, you can see it does lower the quill. Just flip the lever to disengage. So I can position this wherever I want and then engage at that point. But if this was spinning the other direction, I just pull that out and that'll reverse my feed direction. So I just want to make sure I'm going in the correct direction. I'll go ahead and engage my feed. At this point, it's going to feed all the way through the part until it hits. All right, so we went through, we made our first cut, reference cut, and it was enough to just very lightly clean up the entire bore. So I went ahead with my telescoping gauge. I took a measurement, and we have roughly 50 thousandths according to the micrometer to take off of this bore. Now that's quite a bit of material knowing the tolerance that we're looking to hold. So I want to maybe do that in a couple of steps, just to see some repeatability. So with 50 thousandths, I'm just going to go ahead, take another 20 thousandths off, stop, take a measurement. We should be at 30 thousandths, and then so on and so forth. So I just want to get some repeatability. So I'm going to go ahead and make my adjustment here on the micrometer dial. All right, so we went through and we made 2 roughing passes at 20 thousandths each pass. Our repeatability is right on. We're exactly at 10 thousandths left to get to our finished size. So I'm going to go ahead and make that final adjustment of 10 thousandths. So I'll go ahead and loosen up my lock screw. And we'll move our micrometer dial 10 thousandths. And I'll go ahead and lock that in place. All right, now this is our finished pass, so we want to get a really nice finish. I'm going to go ahead and drop my feed rate down. I do have a little bit of roughness to it, so I'm going to go ahead and drop my feed rate to 1/1000th of an inch per revolution. That's going to give me a really nice finish on this bore. So we'll go through, make our final cut. All right, so we went through, made our final pass, our finished cut. I went ahead and took a measurement with my telescoping gauge, checked out our sizes right where we needed to be. We got a good finish, and everything worked out pretty well on this. Today, again, we went over offset boring head, the different styles of boring heads, different cutting tools, and to our finished product here, boring our hole. So That concludes this video. I want to thank you guys for joining us. If you got any questions or comments, leave them below. Hit the subscribe button, and we'll see you next time.